How do nuclear techniques help crime investigations? Nuclear techniques can be used to analyze samples of forensic evidence related to crimes, from drug trafficking to murders or art forgeries. X-ray techniques, neutron activation analysis, ion beam analysis and radiocarbon dating are among the most common methods, which can complement more traditional methods in forensic investigations. Through the analysis of the chemical and physical properties of materials, supported with other forensic evidence, such as DNA or fingerprints. These techniques can help link samples of evidence taken at crime scenes to perpetrators. Nuclear techniques can help specialists analyze microscopic traces of incriminating evidence samples, such as elements in paint or a single hair. This can help to uncover information which could not be discovered otherwise, for example, the true age of forged art pieces or whether an individual was poisoned. Moreover, nuclear techniques are considerably less destructive compared to other methods, such as the use of chemicals for analysis, which can alter the original condition of fragile evidence, for example a tiny shard of glass. Therefore, after being analyzed with nuclear techniques, fragile evidence can still be preserved for further analysis. The use of X-ray radiation is one of the most widely used analytical tools in forensics. X-ray emission techniques are sensitive and reliable. They can be applied to very small samples, and in most cases do not destroy the evidence. X-ray techniques tend to produce results in minutes, and multiple analyses can be carried out quickly. In addition, portable X-ray equipment can be easily transported, which enables this technology to be used in on-site investigations. X-ray techniques can help to detect the presence of, and measure the concentration of, elements in virtually all types of material. They can help analyze the material composition of soil, drugs or minerals and determine their source. X-rays also help in comparative examinations of paint, metals or gunshot residues, and in medical examinations. Scientists use devices such as X-ray fluorescence spectrometers or synchrotrons to bombard a sample of the test material with X-ray beams. The beams interact with the atoms of the sample, releasing radiation, which can be detected and used to identify the element from which the atoms originated. Neutron activation analysis is a technique which uses the interaction between a flux of neutrons and the material being studied to determine the elemental fingerprint of a sample, in other words, the exact isotopic composition that provides information about its age and origin. During NA, when samples are bombarded with neutrons, their atoms release particles and/or radiation, which can be picked up and analyzed by a specialized detector. This can help to determine what the sample is made of, how old it is and where it came from. NA is usually used to analyze the material composition of bullets in order to trace their origin, using very small samples. In addition, analysis using this technique can reveal the elemental composition of hair, which may help to uncover new details about a case, for example, the presence of drugs or other toxic substances in the body. NA can also be used to establish the origin of premium foods and identify counterfeit products, for example truffles, by irradiating them with neutrons and detecting the gamma radiation emitted by the atomic nuclei of the chemical elements in a small sample of the truffle. When this radiation is detected, it can help to match the elements in the sample to a particular location. It can also be used to determine the authenticity of other premium food products.